All right, welcome everyone. Let's get right to it. What if I told you the next industrial revolution isn't going to be televised? It's going to be printed. Today, we're pulling back the curtain on additive manufacturing. This isn't just about a new way to make things, it's about fundamentally rewriting the rules of your industry. So, let's dive in. I want you to really let that sink in. Everything you think you know about manufacturing, the massive factories, the rigid assembly lines, the huge upfront costs, that's all becoming a thing of the past. Something faster, smarter, and way more flexible is taking over. This revolution is already here, and it's being built, quite literally, one layer at a time. So here's our intel drop for today. We'll kick things off with the blueprint, the big picture. Then we'll get into your arsenal, the tools and materials you'll be working with. After that, we'll open up the hood on the digital forge, see how the whole process works, and talk about the game-changing advantages, the transformers. And finally, we'll talk endgame, building a global, on-demand network. Okay, first things first, the blueprint. This is the foundational knowledge, the core concepts you absolutely need to grasp to understand this massive shift in manufacturing, and, more importantly, how you're going to use it to your advantage. So let's talk money. This is the core financial why. On the left, you've got the old world, sky-high capital expenditure for tooling, supply chains that can break at any moment, and lead times that just kill any kind of innovation. Now look at the right. That's the new reality. We're talking near-zero tooling costs for custom parts. We're talking about producing things only when you need them, turning your physical warehouses into a digital inventory. This is a direct assault on the waste and inefficiency of the old model. So what is additive manufacturing really? At its heart, it's actually pretty simple. You're building an object layer by tiny layer straight from a digital file. The best way I've found to explain it? Think of Superman's Fortress of Solitude. You know, how those giant crystals just grow out of nothing into this incredible complex structure? That's what we're doing. We're taking a digital seed, a blueprint, and we are growing a physical object right out of it. And let's be clear, this isn't some new, untested fad. This tech is mature. It actually got its start way back in the 80s for making simple prototypes. By the 2010s, it had grown up and was making real industrial-grade parts. Today, it's a core strategic tool for agile, on-demand production. But here's the kicker, the part you really need to hear. Within the next 2 to 5 years, this stops being just a tool. It becomes the engine for a $10 million a year business platform. So now that you've got the blueprint, let's talk about the hardware. Let's look at the incredible tools and materials that make all of this possible. Consider this your briefing on the arsenal you'll be using to build the future. Now, additive isn't just one thing. It's actually 7 distinct families of technologies, and each one has its own superpower. You've got stuff like vat photopolymerization, which uses light to shape liquid resin into unbelievably detailed things. Think custom dental aligners. And then on the complete other end of the spectrum, you've got powder bed fusion. That's where we use high-powered lasers to forge incredibly strong titanium parts for things like jet engines and medical implants. The range of what's possible is just huge. And right here, you're watching it happen. This is the real deal. This is a process called direct metal laser sintering. You're seeing incredibly powerful lasers dance across a bed of fine metal powder, melting it layer by microscopic layer. You're literally watching a solid industrial-strength metal part being forged from dust. It's like modern-day alchemy. And this is the incredible result. From that bed of powder, you get something like this, a custom medical implant perfectly tailored to a specific patient's body. And you see that complex, web-like geometry? That's not just for looks. That structure actually encourages bone to grow into it, making it stronger. You absolutely positively cannot make something like this with any traditional method. This is where AM just opens up a whole new world of performance. Okay, so you've got the big idea, and you've seen the tools. Now let's go to the engine room, the digital forge. This is the entire workflow, from start to finish, that turns an idea on a computer screen into a real physical asset you can hold in your hand. The whole process is actually pretty straightforward. It all starts with a 3D design, a digital blueprint. Then, some really smart software slices that model up into thousands of paper-thin layers. The printer just reads those layers like a book and builds the part. But then comes the final step, and honestly, it's the most critical one, post-processing. This is where the real craft, the real expertise, comes into play. And I really need to hammer this point home. This tech does not replace your skilled workers. It elevates them. It makes them more valuable. Look, anybody can press the print button. But to take that raw part and finish it to meet, say, aerospace-grade specifications, that takes skill. That takes expertise. The real profit, Your true competitive edge is hidden in the hard-earned knowledge of your technicians on the floor. And we're constantly making their job easier and more profitable. Check this out. Innovations in the software like these organic supports are a total game changer. They look like tree branches. They use way less material, and they're super easy to remove after the print is done. So what does that mean? It means less material waste, faster prints, and way less tedious cleanup for your technicians. It lets them focus on their high-value finishing work. All right, so the digital forge gives us this incredible level of control. But what does that actually unlock for you in the marketplace? This brings us to your new competitive edge. We call this section the transformers because that's what AM lets you do. Reshape your products and your entire business model on the fly. Just look at the competitive landscape. CNC machining, it's precise, but you're literally carving away material, which is incredibly wasteful. Injection molding, great if you need 1,000,000 of the exact same plastic part, but you're locked in by a mold that can cost a fortune. There's zero flexibility. Additive is the true transformer. It can change its shape, its function, its complexity from one print to the very next, with absolutely zero retooling costs. And that ability translates into 4 huge strategic wins. First, rapid prototyping. You can test new ideas in days, not months. Second, on-demand production. Say goodbye to giant warehouses full of inventory. Third, mass customization. You can tailor every single product for a specific customer at no extra cost. And fourth, part consolidation. This one is my favorite. This picture says it all. This is part consolidation in action. In one hand, that engineer is holding a traditional assembly made of 15 different parts. That's 15 different suppliers to manage, 15 potential points of failure, not to mention all the time it takes to put it together. And in his other hand, he's holding this single, 3D printed part that replaces all of it. It's lighter, it's stronger, and it's radically simpler. That is a massive, massive win. So finally, let's talk about the end game. This is the big picture. This is where you evolve from just being a manufacturer into becoming a network orchestrator. This is where you build a truly global, agile, and resilient supply chain. The ultimate goal here is to build what's called a distributed manufacturing platform. The easiest way to think about it, it's the Uber for manufacturing. It's a cloud-based network that lets you print what you need, where you need it, exactly when you need it. Imagine your customer in Singapore needs a spare part. You don't ship it from halfway across the world. No way. You just send the digital file, and a certified partner in our network prints it for them that same day. Shipping costs? Gone. Supply chain risk? Slashed. And here's how you get there. It's a simple, actionable roadmap. We call it crawl, walk, run. In year 1, you crawl. You master the technology inside your own 4 walls. You build your expertise. Then you walk. In years 1 and 2, you build out your own serious production hub. Finally, you run. In years 2 to 5, you launch your own platform and you start orchestrating that global network. It's a clear, step-by-step path to dominance. Now, to lead this charge, you're going to need a new kind of talent, a new hero for your organization, the additive engineer. Think of them as the Neo from the Matrix. They don't just see a physical part, they see the digital code behind it. They see the optimal design, the hidden structures, the things that can only be brought to life through additive. They are the architects of this new world. So there you have it. The technology is here, it's mature, and it's ready. The business model is proven. The roadmap to get there is crystal clear. You now have the complete blueprint to build a more resilient, more profitable, and wildly more innovative manufacturing operation. The only question left is when are you going to start building?